reflection under geometrical constructions 6. So I've got a question here that I'm going to be answering in using 3 different methods. So we have got a rhombus that has got vertices A 2, 2, B 1 minus 1, C minus 2 minus 2, and D minus 1 1. So we want to find the coordinates when we reflect this rhombus through the x-axis and through the y-axis. Okay, so the first method that I'm going to use is the one that involves the use of matrix. So matrix of rotation of reflection through x-axis is equal to 1 0 0 minus 1. Okay, then the one for y is minus 1 0 0 1. Okay, so these are the matrix that I'm going to be using. Then for our rhombus now, we can write its vertices in the form of a matrix, whereby we can have our A as our x, our y, x, y, x, y, x, y. Okay, so I'll write A, B, C, and D. My column vector are going to be following x and y values. So for A, I have 2, 2. For B, I have 1 minus 1. For C, I've got minus 2 minus 2. For D, I've got minus 1 1. Okay, so this is the matrix for our rhombus that I'm going to be using. Now let's do the multiplication of our reflection in the x-axis and our matrix of our rhombus. Okay, so I'll start with A. For A, we want to have our x-axis. We are reflecting with our x-axis, and we said our matrix is 1 0 0 minus 1. It's going to be multiplying with our A, B, C, D. Okay, which is 2 2 1 minus 1 minus 2 minus 2 minus 1 1. Okay, so this is going to be following any other matrix which is row by column, and we should also check if it's a multipliable matrix. So this is times a 2 by 4 matrix. The first one is a 2 by 2 matrix, which is the identity, and the second one is a 2 by 4 matrix. So we check here, we have got same numbers, so we can multiply, and our answer is going to be a 2 by 4 matrix. Okay, now let's multiply row by column. If we do our row by column, we'll have for the first row, I'll have 2 times 1, I'll get 2, plus 0 times 2, I get 0. Then the second one, 1 times 1, I get 1, plus 0 times minus 1, I get 0. Then for C, I've got 1 times minus 2, I've got minus 2, times 0 times minus 2, I've got 0. The last one for D, I've got 1 times minus 1, minus 1, plus 0 times 1, I get a 0. Okay, then we do the same for the second row by column again. So I'll have 0 by 2, you get 0, plus minus 1 times 2, I get minus 2. Then the second one for B, I've got 0 times 1, 0, plus minus 1 times minus 1, I've got 1. Then the next one for C, 0 times minus 2, I get 0, plus, this is plus here, this is plus. Let me just correct this one, it's a plus there. Okay, I've got 0 plus minus 1 times minus 2, I get 2. Then the last one, I've got 0 times minus 1, 0, plus minus 1 times 1, I get minus 1. Okay, now let's simplify that. What do we get? We will get, for the first one, 2, 1, minus 2, minus 1, minus 2, 1, 2, minus 1. Okay, remember this was A, B, C, and D. So these are the images. Okay, so the coordinates or vertices becomes A image is now 2 minus 2, B is now 1, 1, our C image is now minus 2, 2, and our D is now minus 1, minus 1. Okay, so that's for our X. Let's do for our Y. For our Y, we are on part B of the question Y axis. We said the matrix of reflection is minus 1, 0, 0, 1. Okay, so we'll be using this matrix RY there. Okay, let's do the multiplication. We've got minus 1, 0, 0, 1 multiplying by our A, B, C, D, which was 2, 2, 1, minus 1, minus 2, minus 2, minus 1, 1. Okay, let's do our, so this we know we can multiply because it's a 2 by 2 multiplying by a 2 by 4 matrix. From the previous question there, we can have our answer as a 2 by 4 matrix. Okay, so let's do our row by column. Row by column. Okay, if we do that, we will get let's write what we'll get. Okay, for the first row, I'll have minus 1 times 2, I get minus 2, plus 0 by 2, I get 0. The second one, minus 1 times 1, minus 1, plus the second one is 0. So everything that is going to be multiplying by 0, I get a 0. Okay, so we can do that. The next one, minus 1 times minus 2, I get a 2, plus 0. The other one, minus 1 by minus 1, I get 1, plus a 0. Okay. Then the last row, 0 by that, I get a 0, plus 1 by 2, 2, 0 plus minus 1. Okay, then the other one 0 plus, I've got minus 2. Then the last one, I've got 0 plus 1. Okay, so if we simplify this, we'll get minus 2 minus 1, 2, 1. Then here I've got 2 minus 1 minus 2, 1. Okay, remember this was our A, B, C, and our D. Okay, so this is the image. Okay, so we can write the vertices or the coordinates as A image as minus 2 minus 2, 2, B image as minus 1 minus 1, C image as 2 minus 2, D image as 1, 1. Okay, so that was the matrix method. Let's go to the second method where we can say for, okay, now let's look at second method. So for the first one, we are going to look at our x is not changing. So when our x-axis is not changing, it means the x values will remain the same, but our y are going to be changing, and we multiply by minus 1. Okay, so let's do that. Our A was 2, 2. Okay, so if it's not changing, it means our image of reflection will be A image is now, x remains the same is 2, then our y is now minus 2. Okay, then we go on for B. B, we had 1 minus 1. So our x is not changing, so our B image, our A, our Y, our X is 1, is not changing. Then our Y, we have a negative here, and we multiply by minus 1 there, we'll get a 1. Okay, so we do the same for our C. Our C was minus 2 minus 2. So if we go there, our image of C, image of C becomes minus 2. Our x is not changing. Then our y, we have minus 2 multiplied by our minus 1 there, so it's going to be a 2 there. Okay, we do the same for the last one, which is our D. It becomes, so our D will have D was -1 and 1. Okay, so if we do that, D image becomes x is not changing, so we have -1. Then our y is multiplying by -1, so we have -1 there. So these are the image. That's how you do when you are using this method that simplifies or checks that you have done something correct. Let's go for our x. For our y, where our y is not changing, so our y will remain the same and our x we multiply by -1. Okay, so we had our a is 2 b is 1 -1, c is -2 -2. Okay, and our d is -1 1. Okay, so remember our x is changing, we multiply by -1, so our a image becomes -2. Then our y is the same. Then our b image becomes -1. Our y is the same, -1 there. Okay, then our c image becomes our x will multiply by -1, so we'll get 2 -2. Y is not changing. Then the last one, d image, is becoming a 1 and a 1. Okay, so that's how you do this. Now let's look at the graphical method. So for the graph, I'm going to plot ABC, the rhombus. So these are the ABC points that I've drawn here, where I have got my A here. Sorry, I've got my A here. Okay, it's 2 2. Then I've got my B, and I've got my C and my D here. So if we plot, we'll get something like this. Okay, so that's the plot of our ABCD. I've drawn it more clearly like this. So this is the ABCD image that we have. So when we now want to reflect with our x-axis, it means our x-axis is the mirror line. When it is our mirror line, it means we can reflect this image here, that is A, is going to be at the same distance from the mirror line, which is 2 units. So we can count 2 units going down, and our A will be equally and vertically on the opposite direction. We have our A there. Okay, we do the same for B, 1 distance vertically there upwards to the mirror line, so it will be going there. We have our B there. We do the same for C, 2 points, 2 up there, so we have our C there. That's basically how we'll be doing. We'll be checking the points and seeing the distance from the mirror and so forth. So when we do this, we can have something like this. When we have our x-axis as the mirror line, where our points, if you check the points here, my C image in red there, the points are basically on the same distance. C is 2 units from the mirror line. C dash there is now in red, is now 2 units here, 2 units there. So that's how you do the reflection. Otherwise, let's look at the y-axis as the mirror line. We do the same thing there. We look at A, it's now vertically, horizontally now. We've got these 2 points here going this on the left, on the right side. We go opposite 2 units, so our A image will be here. We do the same for D, 2 point, 1 point, 1 point, so our D will be here. We do for B, 1 point, 1 point, B will be here. C, 2 points, 2 points, so our C will be here. So if we are to draw that, we end up having an image like this. And you can check the distances from the mirror line. So basically that's what happens when we are doing a reflection with our x-axis and our y-axis as the mirror line. Otherwise, bye bye guys, let's meet next time.